You know, working with RF, radio frequency, and radios, there's a bit of magic involved. So when I used to fix linear amplifiers, my own amplifiers, I would look at best practices for grounding all the pins on the 3500Z or whatever, and they would run those things in grounded grid. Anyway, typical setup on this thing, I look at a Swan radio, and this GSB-100 is the same way. So they're pumping about 150 volt in this screen grid here, second grid, first grid, second grid, third grid. Third grid's always attached to the cathode, and this second grid here always gets pumped to some screen voltage. So anyway, my point is, the way they wired this thing is they use pins, I think what, second grid here, here's the same tube. The second grid, grid 2, is pin 4 and pin 8. So I don't think they had any capacitor on pin 4. And best practice is when you have these tubes with multiple pins on the same item, in this case item is this second grid here. When you have pins on that aren't used, you basically put capacitors on them if they're not the grid. If they're not the main grid, so the main control grid here, you don't mess with that with capacitors. But these other ones, like the screen grids and all that, they have capacitors on here. They had a capacitor, I think, there, but they didn't have one here. So grid 2 didn't have a capacitor. Anyway, I just stuck a 0.001 on there, and that is just a 1 nanofarad is a 0.001 microfarad. So I stuck one of these Chinese communist capacitors on there, and it seems like it made a big difference, which I can't believe. I'm like, what the hell? So anyway, getting to the bones of it here, you'll see there's one little blue capacitor in there, and I'll zoom into it. That's all I did is added that capacitor because the pin was empty. My light is strobing, I apologize on that. Anyway, you can see that capacitor, that little blue one in there. And that's on what, pin? Is that 8? No. Anyway, there's the pin numbers. Here's how it's wired. So they're feeding bias in. They're feeding bias in through here, and I thought that was a hack from the previous owner, but it wasn't. I think that's how they do it. So this is about 3K right here, and they're throwing some bias in through here. I did replace a wacko capacitor here, like a .25. Just, I doubt that made any difference, but anyway, I replaced that. And that's the bias going into the cathode. They have bypasses on here. You can see a 0.001 bypass there. There's one there. Anyway, here's the new one I added right here. Little blue thing. That took me like 20 minutes to solder that stupid thing on there because I couldn't get in there. So the RF feeds in through here from the 12BY7. And this is the cathode. This is grounded. I think that's the second grid or something. What else is in here? Well, one of these is getting 150 volts. I know that. Pins. Okay, here's the heater. We're feeding it through a big choke. And I guess the heater is pin 3. Okay, this is pin 1, pin 2, and pin 3. Okay, so pin. What the hell? Which ones are the heaters? I don't see how they would put cathode in through there. Let's see. So what they doing here? This is pin 1. No, this is 1. This is 2, 3. So 3, okay, 2. How do they do this tube? Okay, heaters are going to be 2 and 7, so that's reasonable. 3, okay, and 6 are the screen grid, which is also the cathode actually. So you should, yeah. So 3 and 6 is a screen and cathode. So 3 and 6 should be grounded with capacitors, .01. This grid, leave it open because you're feeding the grid. They're feeding the grid, I think. What are they doing here? I think they're going through 5. Pin 1 is open, which is fine. I could put a capacitor on there and it killed everything, so you don't do that. But capacitor. This was the one that was missing right here on pin 4. So, and you can't read this thing. Let's see what the hell's going on. But I think that's pin 4. They're saying this one's pin 4, grid 2. Okay, yeah, so pin 4 and pin 8. Pin 4 and 8, they're feeding it with 150 volts, but they didn't have their side. The other side had no capacitor to get rid of harmonics and all that crap. So I can't believe that would make a big difference. It doesn't seem like it would. I don't see us replacing a couple capacitors here to make a big difference. I replaced, just for the hell of it, I took out some of the crappy capacitors in here, which were really flaky. They had this capacitor in here, which this one whacks out in my fluke meter. It doesn't even measure. It kind of wanders. So this was bad. Could have been leaking. I don't know. This one was over here. I haven't even looked up what these do. I just had to replace them. Anyway, I think I'm ready to turn this thing over. I actually want to replace this jack and put in a new jack, and I think I'll do that now. And then I'll turn it over. I want to put a decent mic jack in here. That's for a phone patch. I can give a damn about a phone patch. I just want to get a decent mic connector in this thing. Let's see, where's the mic? The mic connector is over there. Okay, so I'll be taking out this thing and putting in a Collins style connector, which is not a 1/4-inch phone plug. It's smaller. And there's the mic, so I can just move the mic right over to there and forget about that weirdo mic connection because it grounds. Here's the little Collins style switchcraft that I bought. So I'm going to put this in. This fits the standard Collins connectors. Since I had Collins around here and I have mics for Collins, I thought, yep, this is what I'm going to do. And I like the little skinny one. I like it a lot. So let's do that. All right, that's my update. I'm going to put this connector in and then I'll give it a try and see how much output we have. I was getting like 70 watts out on 80, which freaked me out because this thing never does that. So I can't believe one little capacitor did that. Okay, well, there's still lots of harmonics on 15 before I tried it last time, so we'll see if that's fixed. Actually, I could probably show you that now. Let's see, let's get down to business here. So, I know I'm on 80 right now. Let's turn this thing back on. Turn it on. Oops. On. Okay, we're on. Turning you around. Hold on. How do you like that? Now you're turned around. So at 80 meters, I think all I have to do is activate it and we'll see the meter. Yeah, look at that. So 80 meters. What am I putting out here? About 75 watts. Yep, it's never done that, so happy as peach. What about back on 40 here? 40 meters, let's try that out. See what I get on there. Actually, I'm gonna melt the floor because this thing is, the tubes are on the floor. They're gonna melt a hole in the carpet with the 5U4s. Okay, 40 meters, fired up. A little bit there, peak it, Not a hell of a lot. Okay, so 40. I'm not getting much here. Oh no, wait a minute, look at that. Son of a gunny. It is acting better, isn't it? So maybe there's hope for this thing. I want to use it for 40 AM, so that's what I really want to do with it. Okay, so at 40 meters, I'm getting out how much? Oh, look at that, I'm not nailed here. Let's nail the carrier. Oh, look at that. We're coming up. We are coming up to 50 watts here, maybe. If we play it right, 50 watts. Okay, there's 50 watts. That's more than I had before. Oh, we're not nailed. Okay. Okay, I'm giving it full carrier now. Let's see what it'll do. Tune it.